We live in a world of actuation. Muscles stretched across our bones enable us to move about our environment, to build machines. And likewise, our machines themselves have power systems that dig, dump, lift, push, and pull objects, small and large. Actuators are the muscles of machines. Hi, it's JML of The End Effector. I want you to come with me for a deep tech deep dive into a company called RISE Robotics to learn how they were inspired by human mobility and superhuman strength, and how they are now helping heavy industry to design, develop, and roll out a new way to go beyond hydraulics. I have topic time codes available. Feel free to skip ahead. Let's go visit the RISE Robotics facility.
Places like this with stuff like this. People like this.
A bunch of chains. We'll go and see the founders in their early work building jump boots, just like you'd see in video games such as Portal, as well as the team's pursuit of exosuits to block and tackle, to forklifts and liftgate systems. And there's even a multi-ton robotic arm that's exhibiting some precise control maneuvers. There's no sag, no jolts, and no oil. So how does something like this come to be? It's pretty cool. How does this team design, build, and evolve their work? These were some questions that I had. I'm really curious. How does this work even as a business? Learn with me about how RISE Robotics is approaching all of this and more. Its strategy for electrification, and why does any of this matter? I visited the RISE facility in Boston on a rainy spring day. Stepping out of the rain inside this former auto body shop turned robot facility, I met with the RISE Robotics team. To start off, let's look at the early days of the startup and how the original team learned to build and sell their novel designs. While I was visiting, I saw how they're currently testing these new power systems for heavy lift applications. And I saw what may very well be the world's biggest robot arm going through its qualification procedure. So all of this and more is coming up. I have full-length interviews with the team that are available to End Effector members who are read in. So that's over 2 hours of additional content. So if you want the full scoop, head over to theendeffector.com.
Right, we're trying to make new machines that are very human, right? And like the broad categories for new machines that are human are humanoids and wearables, right? And so we were looking at the key parts, specifically the muscles, which is like your transformer of going from spinning shaft of the ubiquitous electric motor to pushing and pulling ubiquitous, rods like human muscles. And so there's a whole bunch of iteration on like clutches and springs and, harnesses and actuators. And actuators were focused on because that's the most valuable part of the machine around which the machine is designed. So like if you look at springs, they're 1% of the weight and the cost. If you look at actuators, they are a substantial amount of the cost because they are power transforming. If you can advance like linear motion from a power per pound per dollar, then you'll make all the existing machines better and you'll make new machines possible.
So we're getting a sense for how the RISE team used their passion for machines to sharpen their focus on a particular type of machine component, specifically the actuators. Up above the main shop floor, the RISE team keeps a collection of their work from over the years. These are some fascinating prototypes that are tucked away up there. Here's a couple.
Before I showed up, Blake and Aaron and a little bit of Tomas were trying to figure out how to make jumpy boots in the long expedition of trying to make a complete wearable exoskeleton.
Oh, yes.
Yeah, so they were.
So then it looks like the game Portal.
Yeah.
It looks like what she wears.
Yeah.
So this is
fiberglass.
Oh.
That they figured out how to cut fiberglass with a water jet and then orient it in a special geometry that allows for flexing. Pulls against your cap and it bows out as you preload it. And so this kind of brought about all sorts of innovations in springs that they call the fiber block, which is like a very power dense spring. And this would resemble like a car or a truck helical spring. So, so this was kind of like a demonstrator trampoline, a mechanical trampoline to show off these spring mechanisms. But soon we realized that that springs were not the problem of very exciting machinery. All the co-founders in at the early point was the idea of catapult pants.
Wearable muscles.
Yeah,
In
like
the form of pants.
yeah.
But-
It's almost like a cartoon way of saying man amplifier. Being able to bound down a football field. Kind of like in some of those dreams you might have had where you can jump excessively long distances.
Or like jump off of a high object and your pants catch you.
Yeah, and you don't bust your bones. Like, that'd be neat.
Yeah.
That'd be in the direction of superhuman, but how do you make real world stuff do just that? It's almost beyond the imagination. So springs weren't the problem. It was the actuator.
From 2011 to 2017, the team was designing new mechanical concepts in hopes of developing useful machines. They began to learn company formation along the way and even advanced the state-of-the-art for portable air compressors, believe it or not. Things really began to gel once they focused on belt-driven actuation.
It's been almost 5 years of like focused belt 1 to 100 ton form better machines, not yet new machines. So in the beginning it was new machines, springs, harnesses, clutches, actuators, 10 generations of actuators using tensile element. And then the 10th generation is ahead, and then that's when it like clicks in, and then it's that type of actuator generation, but now Rev 1, Rev 2, Rev 3, Rev 4, Rev 5, and then once we get the rev locked in on the 2 ton, then it's like, okay, we got 2 ton pull, now we got to do like 25 ton pull to get a bookend, but then we realized, actually we're still in the middle, like these are not the smallest nor the largest, and then it's like, okay, cool, now we have to do push pull and push. Sorry, we have to do push and then push pull in that order, and then it's like, okay, we got to form partnerships with the value chain.
Before we hear from the CEO about how he and his co-founders built RISE from a frugal startup to a growing player that it is today, I want to tell you a little about belts. So, mechanical belts and mechanical belt drives have been around for centuries, perhaps thousands of years. With industrialization in the late 1800s, it became quite common to have tractors, power tools, and almost anything that wasn't powered by animals, water, or wind to be powered by steam that would spin a belt. If you have an automobile with an internal combustion engine, it probably has at least one belt that serpentines its way among critical components such as the vehicle's alternator, radiator fan, and the air conditioner. Belts are not the bad guy here. In fact, elevators have belts too. They function as pulleys that lift and lower the mass. All of these belts have something that's in common. They are planar. That is, they rarely have twists because twisting of the belt can lead to friction, fraying, and a failed belt. A belt failure could mean that automobile or that elevator and their occupants have a really bad day. But then the RISE team made an observation as they were working with belts that ultimately led them to discovering how to not only get the belts to operate out of plane, but also to pull and push incredibly large loads with incredible precision. The system is effectively solid state, unlike hydraulics. There are no oils or lubricants that are needed. And so the belts also, this is really cool, the belts contain electrical wire that enables the whole belt actuator, the RISE cylinder in this case, to measure its exact performance, its duty cycle, and even raise an alarm before the belt fails. So it opens up an opportunity for really incredibly detailed preventative maintenance on these kind of belt actuated systems. So when the RISE team began to see the potential of their new advanced form of belt-driven actuation, how did they grow a business around these discoveries? Let's listen in.
There's really two parts. There's the discovery period until the Liftgate Air Force venture capital all happened in quick succession after the testing. And that test was really just hydraulic on the left, 2-ton cylinder on the right, compete, and it won. So, and then everything else is kind of built on, well, how good can you actually do that at full production?
So you're just such a culture for a long time of, well, let's build it, and at least at some scale that is meaningful enough to be able to and to be able to show that the design or the materials and all of that comes together right, or where it fails, and then
we were practicing company forming. We were practicing inventing. Like, we had orders from Lowe's and Home Depot and 7 of the biggest power tool companies in the world. Like, our marketing literature drove, our product requirements drove, like, the stuff that we did we moved the air compressor industry. Yeah. Like, you can go and you can see our marks all over the place. Like, everybody followed our lead. Like, we were briefly like the influential little group that people were like, oh, that's cool. How could we do that not using their IP? Because it was 7 years and like 6 months of discovery, and then it's 5 years of like early stage development and commercialization, and then now we're really starting to cross into like noticed land of what's going on over there.
What's going on there is right. Downstairs in the facility, Nolan showed me a heavy lift system that they were using for demonstrations. It is a pulley, ultimately, but includes several novel patented aspects to the design.
This is the block and tackle system in our 25-ton tension demo unit, which we designed and built and tested about 2 years ago.
This, 25-ton pulling linear unit, complemented by the belt power unit, can make it so that way the forklift can do more work in the same amount of time. So for the manufacturers, as a first fit machine, instead of using a hydraulic system, and then it's going to the rod, which is connected to the forks that are doing the up and down or the steering left and right. There's pros and cons to everything, but the hydraulics run off of electrical power. They're not very efficient. The belt was pioneered by the elevator industry to replace cables.
In the early days, RISE was trying to find like the best medium to transfer force or load, and we've settled on the belt as kind of one of the most like resilient and like industrial types of one of these mediums, which is why we're able to do what we're able to do.
This is just one specific tensile element, and broadly we tested and developed a variety of tensile elements.
Okay, so wow, so yeah, I mean it looks like a rubber belt, but it's actually not.
No, there's steel wire inside.
Yeah, there's in this one I think there's 6 stainless steel core wires with a polyurethane sheath. We have one end terminated here, which does not move, and then the belt is wrapped around all of these pulleys, and that's where the block and tackle comes in. This moves up and down, and then all of this belt, which is obviously outside of the system now, goes to that belt power unit that we were talking about, which transfers some kind of rotational energy, and maybe from a motor into linear motion when this is kind of pulled along.
So the design of this, I mean, it looks like relatively straightforward from a pulley science perspective, right?
It's a little novel. So the pulley assembly, you'll note that the pulleys are different sizes from each other, such that all together they are round. Yeah. That is novel. And the reason to do that is to map from one pulley assembly to the other pulley assembly, compensating for misalignments. And there is a patent on that aspect of the rotational. high utilization.
And is that then, as we go
That's
through
everywhere.
to the
We're
generations,
see that over and over.
it's gonna,
So right now we are essentially a program development company that is our end state for this epoch is to have product that is then a recipe that is made. So we're in the low revenue initial production phase, barely, and we're mostly in the development of all the different sizes. So far we've just shown you the 25-ton pole, right? Before that we had the 2-ton pole. Before that we had not even in the world of tons, right? We were down in the pounds.
seeing a relatively compact belt system that can pull 25 tons was cool. But how does RISE develop something like this? How does RISE go from designing portable air compressors to multi-ton belt-driven push-pull actuators? We all know how a rope can be pulled, but pushing a rope is not really possible. Or is it? I wanted to learn, how does this team test their designs? How do they think? And so we visited a test rig that RISE has used to empirically determine what their belt approach could do. This is, you mentioned, someone said this looked like a torture device, but it looks like you're going to torture and test.
Belts, yeah. So we affectionately refer to this as just the belt tester. When flat belts were identified as, a very likely candidate, it was decided to build this machine. And what we're able to do with this is test belts under varying fleet angles, which is when the belt is laterally moved and also twisted. Manufacturers of elevator belts tell you not to fleet and not to twist belts. It focuses the tension on a smaller number of the stainless steel core wires than recommended. So say, there are 6 stainless steel wires in here. If it's fleeted however much, then 2 of those wires will be strained more than the rest. That will make those 2 wires fail quickly, which will make the rest of them fail because now those won't be able to take the loads. So by tensioning and then fleeting and twisting in equal and opposite amounts, we're able to normalize the tension across the entire belt width. And that's important because it can increase lifetime of a belt, which is fleeted or twisted, from, say 2% to 95% or something like that.
We were at Greentown Labs, and we had switched from BHA belt, which was more like a wire rope with a jacket, to this kind of stainless steel wire impregnated polyurethane belt. And we were doing stuff to it, like we were misaligning it and we were, twisting and fleeting it, and it was running on a constant test. So then, shortly after that, we hired Nolan and a couple other people, and Blake and Tomas had built this and verified what the math showed experimentally. So then we verified it 5 times over, and then did the whole gamut of, for this fleet, for that twist, for this fleet, for that twist, at this load, at that load, and we basically characterized the curve. It also needs the belt power unit and other tension managing, over tension, under tension, loss of tension. Hydraulics are in a realm of pressure management, and belts are in a realm of tension management.
So we basically dipped this in a freezer and went down to -40 and tested the belts in the same way. And said, all right, in Alberta in the winter, mid-January, how is our system going to perform?
Ultimately, we're going to drive the cost down of all the machines. But right now, it's really focused on where does productivity drive down cost, and where does efficiency drive down cost. It's the fastest way to learn. This style of study is how we figure things out real fast. Before, it's prove the principle of managing belt tension, right? In the specific circumstance of this belt, that pulley, that bearing. It was the beating heart of the company for a long period of time. This was treasure to us.
So this is an example of a belt that we have tested on here. We basically weld, our flat belt onto some kind of timing pulley, tension this up with a load cell, to simulate kind of the max load case. And then with the motor gearbox, we rotate it on and off the pulley for, millions of cycles, simulating, what would that one piece of belt do in the RISE cylinder? How many pulleys does it go over? And then we're able to, from there, extrapolate life data and understand what the belt is doing at its 9th year of life out of 10 or something like that. We have, for our 4,000-pound cylinder, a 25-foot tall test rig that we lift 3,500 pounds on. It starts with the user and how they use the machine, how often do they use the machine, to what extent are they putting the machine through its paces. We're able to say, okay, in normal use, it should last this amount of years or this amount of cycles at an average of this load. We're able to then kind of look to the end of the design process, say, all right, well, when we actually design this, it needs to do all of these things. That informs our requirements.
It's kind of interesting because, in the very early days, we had a desire of a new type of machine when we realized that we needed better actuation. And when we came up with that better actuation, it was like, oh my God, this could solve today problems. Is this the right load class? Oh, it won't last long enough for this application. It's going back and forth, and eventually you find a low-hanging fruit in which what you have already could go in that place where all these metrics can be met on what we have demonstrated in the lab. And it's like a serious back and forth. And I think around 2018 is where we were like, oh my God, we have something that.
And then that part that you mentioned, Kyle, is that I think there's a passion for and a diligence to talking with how do you organize that information in it, in an interview format or I don't know, feeling, meditate on it or what?
Yeah, pick up the phone kind of a thing and just trying to figure out what is the business problem, what's the burning pain point? What is often maybe one trick is saying, if you had a magic wand to fix the one thing that annoys the crap out of you in your day-to-day with this machine, what would it be? And kind of get a pretty good signal that way. Those are the things that they talk about, are the things that they notice, that if they were to see that change, they would notice it.
And really want to dive deep and, say you do win a contract or you sign a partner or you want to talk to different users, going in and actually seeing them use the machine.
You got to go to know. You really have to be intuitive with the problem before you pick up that engineering pencil. Otherwise, you have the problem that you'll hear a lot of people in the area talk about, which is technology in search for a problem, which is kind of a weird way of going about doing things because you're never going to guess right.
So, having observed how RISE learned how belts could handle the range of forces, temperatures, duty cycles, and the overall operating environments that potential customers would hope to see, I started to dig into the business aspects of the company.
So there's 3 levers. There's project, people, money. In the beginning, there's just the people with a dream, team in a dream they call it. So you get the team and the dreamer first, and then a little bit of money comes in some form. In our case, it was an angel investor put in some money. So then now with the money, the team and the dream make the project. And investors are just an analog for customer money. So if you've got a customer, then you don't need the investor money because the customer will pay you. But if the customer won't pay you, but you believe they will, you get investor money. So then it just kind of ratchets. So one really simple call to action for us is, let us show you how we can make your machine better. If my machine could be more productive, and if my machine could be more efficient, meaning if it could do more lifts per fuel, or it could do more lifts per hour, then that would be great.
So I learned that RISE is not talking to one particular customer. It's talking to, in the CEO's words, all of them, and receiving digital data first about industrial equipment like pressure and stroke and force. RISE had recently received physical hardware when I had visited. It received a forklift like you would see in any warehouse. And from one of this was coming from one of their partners. So we looked at how will this team assess this particular work lift to get it ready to be have RISE kind of implemented inside of it as its actuation system.
We'll take out the linear motion unit, which is the cylinder, and then we'll take out the power unit, which is the motor, pump, reservoir, manifold. So we'll put a cylinder here, and we'll put a belt power unit here. So we kind of generally think of them as like phase 1, 2, 3. And phase 1 is generally that virtual, like what's possible, right? What's the cost benefit analysis? Like, what is it now? What would it be after? Then phase 2 is like, give us the machine, and then we'll modify it. And then phase 3 is like, let's produce a machine at volume. You really want to be bookended by your like value chain, right? There's a tool called Wardley, WARDLEY, like value chain analysis. I like to use it as like a way to kind of map out like who do I need around us.
We're kind of like living in an age where people have accepted electric cars, right? It's rotary electric. We moved away from the combustion scenario. So there's a different infrastructure, and that on a car, totally different layout of components. Nobody has the capacity to imagine a fully electrified heavy machine because, well, right now it requires a lot of space for the big batteries.
An often asked question is, could you just aftermarket plug and play?
Like fit in
could
place?
You just take this out and put this in? In a very small subset of machines, yes. In most machines, no. So what we did is that 25-ton pull unit, we just Frankensteined it in here.
Okay.
And then sometimes, because our tech has the ability to do variable speed, we can actually do away with excessive actuation points. So the application
Because of
side
a
changes a
precision
lot.
element.
A RISE cylinder provides a way to deploy basically a robot system architecture on stuff that was not roboticized.
Yeah, you can make like a rookie operator as good as a pro operator. Even the pros can gain.
Manufacturing or heavy supercritical payloads.
Incorporating belt-actuated cylinders into forklifts of all sizes is a big opportunity that the team is pursuing. So, I looked into it, and for example, Class 5 forklifts, which are the biggest of the big forklifts, they operate in major maritime ports globally. So the company is positioning its actuators to serve this need of the ports, such as those that are within the state of California, that are striving and really challenged to reduce their overall emissions while still increasing the flow of goods.
California is saying, we did the analysis, and these machines are making a outsized impact on emissions. So since we control ports as a government, and we can inspect and authorize, like California just straight up said, starting now, we are beginning the transition to zero emission heavy machinery. And by 2026, big fleets better have 10%, and by 2030, you better have zero diesel emissions. The market goes vertical in 2030. How many dollars do I have to spend on all of my container moving thingies, right? And how much do I have to spend on each move?
RISE is properly viewed as like a red cylinder, but really it's RISE and its value offering is going to be more like full vehicular platforms kind of like that, or
we're willing to provide as a service help to our partners to put it in there.
Like the digger dumper companies of the world.
Yeah, but a lot of them have that and know how to do it and want to do it. But if they want any help, here you go. You basically, it's just a service. Yeah. So our goods are largely the cylinders and the belt power units, but then our services are,
like tailored vehicle.
In the case of the DoD, we actually are doing the full arm. So we actually are doing the work function there.
I'll come back to what RISE is doing for defense a little bit later, but first, let's see how they have built a way to test push-pull loads without having to move a bunch of weights around. So, it turns out they developed an interesting centrifugal system that applies precise loads easily and enables the team to assess how their actuation cylinders will hold up under more duty cycles and ever greater forces. This kind of test fixture is a great way, I've learned, for the team to be able to learn faster and be able to put a lot more sort of confidence and data around the performance of their systems?
Yeah, so currently we have what we call internally the double acting test fixture. That's this whole apparatus here, and it's designed for characterizing the double acting cylinder. We have a load cell, we have a string pot for getting position, we have current data, we have the limit switch indicators. You don't want to be crashing into things. So all that information we use to kind of make sure the system is healthy and doing exactly what we expect it to do. And that's when we find anomalies and we're like, whoa, the current's way too high here. That's when we kind of start looking deeper into the design scene.
I can't imagine how eye-opening it'll be when like a port manager can see across the fleet.
Yes.
What's happening, like literally at the time, and it's sort of duty cycles and when we expect it to fail, and if it's been mishandled in some way, like that's insane.
I mean,
Money can't buy that.
Yeah, no.
if we can stream all this data to a PC, it can go over the air. Yeah, so on the oscilloscope specifically, we wanted to capture the torque sensors data so that we could start doing efficiency testing so that we can get the actual mechanical load or the mechanical efficiency compared to, say, the electrical efficiency. And then we're going to compare those two and see what the overall system efficiency is.
To show the prospective customers that, like, for every electron they're putting into this system, they're getting like 80% or something of work compared to probably a traditional.
Yeah, hydraulic can't regenerate. Best of days with the shortest hose lengths, 45% in one direction. Not even thinking about the lost return stroke.
Right.
Yeah, you can't really.
Oh yeah, like we're going to be testing regen as well.
Yeah.
Yeah. So
I mean, it has regen by default because it's direct drive, and if you don't manage that excess power, something explodes.
Yep.
okay.
The motor has to, kind of provide that negative work, provide that reverse torque, and that's going to put regen power into the system. Because at that point, the motor's acting a little bit like a generator. And so we have a return path built in, and it's just a second wire with a diode to allow power to go back into the battery.
So you can think of anything to the left of the orange cylinder as an analog for hanging weights.
Okay.
So essentially, in order for us to not have to load weights up and down every day, because nobody likes doing that, and we also wanted control in both directions and being able to provide the 4 quadrants of work. We devised a flywheel system where the load is a function of the acceleration of the rod. And right now, the steady state load of the system is 700 pounds. So you're seeing 700 pounds being pulled right now.
So I was able to stand near a prototype of the full arm that RISE is developing for the U.S. Air Force, because there is a push among the Department of Defense to modernize all of the lifting equipment. Once it's put through its paces, this robot arm will be used to load equipment into aircraft. The arm is extremely precise. It's really quiet, and it's able to lift multiple tons.
This is a prototype 6-degree of freedom lifting arm for the purpose of loading munitions onto aircraft for the U.S. Air Force.
Pilots are sitting in planes waiting to go because the loads take too long to load. So one of the things that this does is not only is it really fast, but it gets to where it needs to be, and we know that it's there. So like imagine that you've got 2 holes, right, that are like a 1/4 inch, and you have to like align them and then pin them, right? So it's like pin the load. It's like pin the tail on the donkey. Right?
Yeah,
like,
and the current difficulties that the Air Force sees with that is the current hydraulic system is extremely finicky. There's a whole bunch of different leaks that occur, and it becomes evident in some of the valving and other aspects of the hydraulics that when the machine comes to a stop at a certain location, there's actually some amount of oil bleeding out of the cylinder, which causes the load to move in an uncommanded way. And so going back to that point about non-back drivability earlier, these actuators and this system ensures that, there is no like hydraulic oil keeping it up. It's all, metal on metal, not going anywhere, very rigid. And so that will increase the speed at which the operators are able to load the munitions, because there isn't someone, ever so slightly adjusting for an uncommanded motion that causes a lot of difficulties when you're actually loading these things up.
So I might have been in the presence of a future world record holder for the world's most powerful robot arm. It's pretty wild to think. So there's a world record attempt, right?
Yeah, let me walk you through my thought process. So I work here all day, and so this robotic arm is moving right next to me, and I'm just like, that looks really similar to one of those industrial arms they have in factories, KUKA, FANUC, that kind of thing. And I was like, wow, why isn't the Air Force just using them? And so I looked it up. I'm like, what is the strongest robotic arm that exists? And there's actually a Guinness World Record for this, and it's one of the FANUC's robotic arms. And I was like, asking around, how much load can this do? And people were telling me 3 tons. I was like, oh my God, did we just break a world record?
Well,
and
the FANUCs, watch out.
Right.
Got it here.
So, where's this? Where could this be headed? This arm?
So this arm is for munitions handling for the Air Force. Tons, somewhere between, and under 3 tons. So we're meeting that requirement, and that's what kind of pushed us to actually build this machine, which just so happens to maybe beat the world record.
Where may we begin to see RISE cylinders in action? Well, potentially, almost anywhere there is some sort of industrial application that would require motion. So, for example, I learned that lift gates on the back of box trucks, that's one big area, but also forklifts, aircraft handlers, and so much more. There's even demand for reliable actuation in areas like the deep sea and maritime use for clamping off pipes and pressure hoses.
We know the bounty is high. Sometimes it could be really boutique applications, oil drilling platforms. And that's above water. It's still salty air.
Yeah.
But if a hydraulic circuit goes down on one of those machines, it can cost the company up to $6 million an hour. And when they go down, it's because it's hydraulics. You can't tell when it's going to go down until it stops moving or it's blowing out fluid everywhere.
Yeah.
And I'm like, we can tell when it's going to break. How do we get in there? Please, how do we connect these dots? Because you cannot do that with hydraulics.
It was really incredible visiting the team at RISE Robotics. I hope you enjoyed this deep tech deep dive, seeing how this company is systematically exploring the fields of mechanics, robotics, actuation, control systems, and so much more. I have collected several learnings from this visit that I think are helpful to highlight for the overall community of science-advantaged companies. We can all learn from each other. And so let's get into a couple of these points. The company's really leaning into testing to see what physics allows, sort of getting that ground truth empirical knowledge. They've been systematically characterizing how their designs succeed, and importantly, how the designs are failing so that they can figure out what will make it even better. The company really accommodates things like important areas like industrial design. There can be challenges in integrating the different mindsets of engineers, designers, business managers, and all the other functions that when they come together well, it makes for an awesome team and an awesome sort of capability and company. And so it looks like from my perspective, this company's done an effective job being able to bring together different mindsets in a healthy and kind of diverse way. The company overall is working in a space that I would say is seeing favorable tailwinds in terms of regulatory environment. There are national sustainability goals that are putting a critical spotlight on hydraulics over diesel, which is one of the most common ways to actuate large equipment. I think the company has some challenges. I mean, and it has to educate the market, so to say. And that does have costs for personnel, just the time and money and patience to be able to show prospective partners and customers why the bed actuated approach is better than what the prevailing approaches are. I'm excited for how if we have equipment with RISE inside, that these machines of heavy industry can become more like robots that can enable junior human operators to become more proficient, while enabling expert operators to become, well, superhuman. It's really exciting and to be able to have a robot system architecture on these mobility and heavy duty platforms can enable safer operation, more precise, and so much more. The company has been doing something interesting as part of its commercial path. It's been setting up unique partnerships with industry players. And it's usually challenging for a startup to find its initial customers and then set up those partnerships that align interests. And RISE has been balancing being able to make sort of unique kind of per company contracting that respects both the needs and stage of where the startup is, as well as where the typically much larger customer is in terms of their business interests and engineering capabilities. I also think that by cultivating core expertise and designing for optionality among the opportunities is something that RISE has done well with. From high precision multi-axis lifts for aircraft that we saw, to simply lowering supplies off the back of a truck. The company has diversified its offerings and continues to pull in more partners while accumulating evidence for how their approach is ultimately going to be the superior offering. I wanted to note that at no time was I paid by RISE Robotics or sponsored by them for this piece. I asked the founders if I could come visit with a camera because I think they are working on capabilities that could help our society transition to a cleaner, safer future. And something that what they've been experiencing is we can pull learnings from that for other science-advantaged startups globally. So I'm really excited, for what kind of learnings that you may have had. So what do you think? What would be other applications for RISE cylinders? Who else is doing cool stuff in actuation? Let us know. With that, stay safe, stay healthy, and remember, no one builds alone.